Good morning, guys. So the other day we worked with triangle sum theorem, right? We worked with knowing that the interior angles of a triangle always add up to 180. What we're going to work with today is something called the exterior angles theorem. And again, we've worked with interior and exterior angles before in a different regard, but now we're actually going to apply it just to triangles, right? So when it comes to exterior angles, right? Let's say you have a triangle. And we know, again, whenever it's the interior angles of a triangle, it always adds up to 180 automatically, regardless of the size. But what exterior angles are angles that are outside of the triangle, right? And the way that it looks, it's literally angles that extend like this, angles that are outside, right? And those are exterior angles of a triangle. So when it comes to the exterior angles, first I just want to show you how it looks. When it comes to the exterior angles theorem, it doesn't apply to all of them, it just applies to one relationship, right? And so whenever we're actually applying the exterior angles, we're looking at it in relationship to one, right? And so when it comes to this, we know that we have, let's call this A right here. I'm going to use a different color. Let's call this A right here, right? Let's call this B, and then let's call this one outside here. Let's call that X. And so what we know is the relationship itself says that whenever you add those two, whenever you add these two remote interior angles, and what the remote interior angles are the two angles inside that are actually away from X. They don't relate to it. It's never the angle right next to it. It's never the angle that forms the line. The two angles that are inside of a triangle that are away from the exterior angle, whenever you add those two up, it's always going to give you the measure of the exterior angle. Always. That's always going to be the case. Whenever you guys have the exterior angle, the measure of the exterior angle is always going to equal the sum of those two remote angles inside, automatically. And it's always going to be the case. And the reason why that is because, let's say we have a triangle, right? Triangle adds up to 180. Forget about that for now. Whenever we have a line adds up to 180, right? So since the line adds up to 180, the triangle adds up to 180, there's the common relationship. So since they both add up to 180, if I were to make this, let's say I were to make this 100, right? Just making something up. If that's 100, automatically that's 80 because those two add up to 100, 80 a line, right? If this is 100, what's left over is 80 because, again, triangle adds up to 180. So if that's 100, those two have to be 80, 80, 80. That's why they're always the same because, again, it's this common angle that they share. But when it comes to exterior angles, always remember, guys, whenever you add up the two angles away from it, inside the remote angles, whenever you add those two up, it always equals the exterior angle. And again, it seems complicated. It's actually very simple to use. And I'll show you. Very, very simple. So let's say, for example, again, you have a triangle, right? That has an exterior angle right there. Let's say that this here is 70 degrees. Let's say that this one here is 40. And let's say I wanted to solve for n, right? Again, always remember, whenever you want to find the exterior angle is always the sum of those two, right? So since that's 70 and that's 40, to figure out the exterior angle, we would just do 70 plus 40, which would give us 110. That's all it is. And whenever you want to find the exterior angle, it's always the sum of the two remote interior. It's always the sum of the two angles that are away from the exterior angle. And you always add them to find the exterior angle, right? And again, that's what's different because now if you wanted to find, let's say, the measure of one of the interiors, right? Let's say I wanted to do that, right? Let's say now that this is 150, right? Let's say now that I tell you that this one here is, let's say that's 40 degrees, and I wanted to solve for X, right? Now think, instead of trying to find the exterior angle, we're trying to find the interior, right? So we're saying that 40 plus something equals 150, right? And we can write that out. we know that x plus 40, we know that those two interior, that x plus 40, it's going to equal 150. And once you have that, again, now it's easy to solve for x. Get rid of the 40, cancel it out. Opposite of addition, subtraction, subtract. That cancels, right? And now we have that 150 minus 40 gives us 110. That's all it is, guys. Just always remember. And it's easy to check too, because if that's 40, if this one here is 110, 110 plus 40 gives us 150. Okay, so the easiest thing, whenever it comes to exterior angles, guys, if you're trying to find the exterior angle, add the two interior angles that are away from it. If you're trying to find one of the interior angles, subtract the exterior and one of the interiors, because they will always give it to you. And again, it's just being able to see what the difference is, guys, between the two. It's the most important part, right? So again, let's say that this is 20. Let's say that that's 60. Let's say that that is, sorry, I got 100. Oh, this is horrible. I want the numbers to work out, guys. And again, these numbers right there, they don't make too much sense. So let's say that this here was 53 degrees. Let's say that this here would be 45 degrees, right? If I wanted to solve now for f, right? And always identify it. What does f represent? F represents the exterior angle, right? So if we're trying to find the exterior angle, if we have those two interior, you want to add them, right? So f would end up equaling 45 degrees plus 53 degrees, which would end up giving us 98 degrees, right? Again, whenever you want to find the exterior angle, you always add. Whenever you're trying to find one of the interior angles, you subtract, right? But again, you have to make sure that it's not just any two angles. You have to make sure it's the remote interior angles, the two that are away from the exterior angle, right? And then again, if they give you this, okay, let's say that they give you, that's 173 degrees. Let's say that this one here is 62 degrees, right? And I'm trying to find the measure of one of the interior angles right there. Again, we know that whenever you add those up, it's going to give us the exterior. So A plus 62 equals 173, right? To solve for A, do minus 62, minus 62. Those cancel, and we know that A is going to equal 111 degrees. Which again, always feel free to check, guys, because 111 plus 62 gives us our 173, always. Again, it's just getting used to seeing it. I want to do one more now that's actually going to write this as an equation, just to get you guys practice with solving equations, but it's still the same concept, guys. Still the exact same idea, right? If we're applying an exterior angle, let's say that this is 5x. Let's say that this is 20 degrees, right? Let's say that this is 3x plus 70. Let's say I have that, right? Again, it looks a lot more complicated, but it's still the same exact concept, guys, because over here, and I'll do it in a different color. If we're looking at this, we know that that's 5x. We know that's 20. We know that the exterior angle is 3x plus 70, right? We know that when it comes to this, the two remote interior, we have to add them. And when we add them, it's always equal to the exterior, right? So write that out. We know that the 5x plus the 20, we know that when we add those two interior, it always equals the exterior, always. Whenever we add up the two interior, 5x and the 20, it always equals the exterior, 3x plus 70. Because now once you have that, it's just solving an equation, right? And I taught you a trick. Always get rid of the smallest variable to make your life easier. We know that the smallest variable is the 3x. Opposite of a positive 3 is a minus 3x, right? Subtract it there, subtract it there. The 3x cancels out. We're left with now 5x. I'm sorry. I'll do this up here, right? We know that 5x minus 3x is 2x, right? We have plus 20 equals and we're left with 70, right? Because now once you have this, again, all you can do, and all I did was just cancel out the 3x, right? Now once it comes to this, you want to get rid of the 20, so opposite of a positive 20 is a negative 20. Subtract 20, subtract 20, right? We're left with 2x equals 50 degrees. Now all we have to do, again, cancel out the 2. Opposite of multiplication is division. Divide that by 2. Divide this by 2. The 2's cancel out. And we're left with x equals 25 degrees. That's all it is, guys. And then again, if we wanted to check it, we could substitute it, right? We know 5 times 25 is 125, right? We know that 3 times 25 is 75. 75 plus 70 gives us 145, right? That's 145 right there. If we add up 125 and 20, it gives us 145. We're right. Again, always remember, guys, exterior angles, angles that are outside. And whenever you add up the two remote interior, it always equals the exterior, okay? Take care, guys.